Now this is something that needs following up. And following up means getting a little more scientific and, in particular, making it a bit bigger so that friction has less effect. A gyroscope that can move about the vertical axis, and when I undo this clamp, it has the freedom to drop as well. It is a more sophisticated model of our gyro on the tower. Let us spin this one up and see what happens. Isn't that a beauty? You can see a little nutation taking place. I can do the trick I did with the two whirls. I can make it rise up by pushing it a little faster. Notice the precessional speed now is very large because the torque is very large because the gyro is offset a long way. Now, suppose I'd clamped that there and tried to rotate it at that same speed. Watch what happens. Why did it topple? I can't get up to anything like the speed I should do before it wants to take off. It appears to exhibit no centrifugal force. Suppose we were to take this gyro out and put it in a box so that you couldn't see that there was something in the box that was spinning. I'm going to spin it up, put it in the box that you can't see, and then we'll weigh it, and then we'll put it back on there, and we'll ask a question. They're quite things to handle these when they're moving. Right, put him on the balance. And he weighs about 30 ounces, nearly 2 pounds. We put him on the machine. Can you tighten up the nut, Bill? Thank you. Unclamp the middle. There is a black box containing you know not what. And I give it a push the other way. There it goes. I've pushed it round. There's a 2-pound mass with a real angular velocity and no angular momentum. No angular momentum except from the dead weight. It's not rotating. Because if I want to stop it, there's no energy required to stop it, no energy release, because I didn't give it any when I began. Let us go one stage further with this to something bigger, something more scientific we can make measurements of.